Hi guys, it's Ajit here and welcome to your channel one more time. So let's understand now under which network design we have to use BGP weight attributes and under which network design we have to use a BGP local preference to advertise the BGP outgoing traffic. And moreover, we also need to understand under which network design or circumstances we have to use other attributes or other feature like access list or route map or prefix list or something else that can help me to advertise the BGP outgoing traffic. So let's start this video now. And before we proceed further, so do not forget to like, share, and subscribe the channel. And we are going to discuss about the weight and local preference, which is one of the most common used BGP attributes to influence the outgoing traffic. So let's understand first weight, uh, its feature. So as you can see on the screen now, so weight is a Cisco proprietary. That means it is only work on Cisco router. Number two, it is local to router, so the values that it learn will be local to the router itself. And number three, it says a default value, which is 0 for the route it learn. So router, for example, if router A learn the router, any routes from router B. So let's take like this in this scenario. So if I have this router and this router, and if router R1 learn any subnet from R2, let's take an example 2.0.0. So for that, its default value will be 0, and any routes that it originate itself. For example, R1, if originates any routes, its default value will be 32768. Okay, so I'm sure that's clear to you. So let's move to another part. Let's take this example here. As you can see here in this network design, uh, or here, if I let me check. So this is my AS number 1. Now this has a router R1, R2, and R3, as you can see on the screen. So in this network design, as you can see, router R1 has two exit path. Okay, with this interface, this one, let me just select for you. So one this interface ISP1 and another with the ISP2. Now here again, if I have to by default in your situation, let's take an example, all the preferred routers, routes are going outside your network via ISP2 here. Okay, or if you want to make ISP1 as a preferred interface for all your exit routes, any routes that should go outside your router R1, it should prefer the path R ISP1, not ISP2. In that case, what you have to do on the ISP1 interface, you have to increase the weight value more than on interface compared to ISP2. Okay, so for in this case example, ISP2 has weight value equal to, for let's take example, it's a default 32768. Then if you want to make it preferred, make it as a 4000. What happened that any routes that will go outside your network will go via to ISP1, not ISP2, because we have increased the weight value and highest is always preferred. As we already know the main feature of BGP weight attributes. So you can see from here that number one thing is that it is local to the router. And number two, it is a Cisco proprietary. So it will only work on the Cisco router. Now let's take another scenario here. As you can see on the screen, let me expand this for you. So you can see here in this screen. So we have AS1, AS2, AS3, and AS4. Sorry for my wrong rough diagram. So as you can see here, let me take the black pen for you. Okay. Now from here, as you can see, if my router 3 has two exit path, one via AS2 and another with AS4. This is my AS4. So if AS2, originates, uh, send any routes to router 3. Let's take an example 2.0.0.0/24 with AS number 2. And same subnet will be learned via AS2 and then AS3 and then AS4. And as you can see from here to here and from here to here, it will come to this interface. So we have two interface, one interface where RT will receive this route via on this interface via AS2, only one AS path, and another on this interface. Here it's learning the same route via AS2, AS3, and AS4. By default, as we know, for incoming traffic, router 3 will install the best route as AS2 because it has the lowest AS path. Okay. Now to to influence the outgoing traffic, what we can do, we can uh, make again on this interface. If we want to make this as a preferred interface, this one as a preferred interface, what we can do here, we can increase the weight value on this interface to more than this interface. So for example, if this interface has a, by default its value is 32768, I can make on this interface 4000. So the traffic will move to via this path direction. Okay, that's another way to understand here. Now the problem will start here in case as this, you know, R1, R2, and R3, as you can see here in AS1. Let me say, this is my AS1. So R1, R2, and R3, they all are part of AS1. Now, in case if router 2 wants to advertise, any route outside, okay, so it doesn't know that this is the preferred path to go. Why? Because this values which I have added or increased here, that value is local to the router itself. It's not, to the entire AS. Okay, so if this router 2 or router 1 wants to prefer this path, you know, they can do, because they can, what they have to do, they have simply have to do the same thing. They have to increase the interface weight values, and instead of going the traffic via, which we have selected via this path, they can try to influence the traffic via this path directly. That means from R1 to R2, R2 to R3, then it should go to AS3, AS2, correct? Because the values which we have added here, that is local to the router itself. It's not local to the AS, and that can create the chaos in the network. So in order to resolve this problem, we have the another BGP attributes which we are going to discuss now, and that is our local preference.
भाई मजा आया और मैं ये जो मजा है हिंदुस्तान के हर व्यक्ति को देना
So in terms of local preference, as we all know, local preference highest value is preferred, and by default its value is 100. Okay, so let's take an example. In the same example, if I have uh, AS1 here and I have router this, and that is connected to another AS2 with this router, and this is connected to another AS. Let's take this example, AS3, and this is connected like this. Okay, make it this AS3. Now, any changes, if I increase the, for example, again, same subnet. So again here, so if this router originates 2.2.0, okay, the same thing here, it will learn the same path from AS2, and again another, this interface will learn the same route from AS2, then AS3, and then it will learn here. So you can see here again the same situation, same scenario, and preferred will be uh, AS2, because to receive the packet. Now, if we have to influence the outgoing traffic here, what we can do, we can increase the whichever path which we have to preferred. If this interface is preferred, we can increase the interface local preference value here more than 100, because here this router also local LP value will be 100 by default. In this router also LP value will be 100 by default, right? Now, if I want to make this path as a preferred, for example, this interface as a preferred, it should go to via AS3 and then AS2. Then what I can do, I can increase the value here from 100 to, let's say, let me open it again. So from 100 to, I can take as a 200. So on this interface, I will put the LP value of 200. So now this will be applicable to entire AS. And now router, for example, if this is router A, this is router B, and this is router C. So router A also knows, and router B, both router knows that to uh, any traffic that should go outside of this AS1, it has to follow this interface and not this interface. Okay, so it all depends upon your requirement and how the network has been set up and how you want to influence the traffic. I'm sure this part must be clear to you. So let's move to another section where we'll be learning uh, how you can use the access list or the route map to influence the outgoing traffic. So guys, now as you can see in this network design, where my requirement is to advertise two prefix with the two different ISP. So now what I want to convey the message here is like, let's take an example. So my LAN is, advertising two subnet, which is 1.1.1 and 2.2.2/24. So what I want that 1.1 should advertise via ISP1 and 2.2.2 should be advertised via ISP2. So in this case, weight and local preference both we won't work because as weight is local to the router and local preference is local to the AS, but that work for the entire prefix, and there is no way that you can filter the network. But here, I want to advertise my subnet, but conditional advertisement. Okay, so here also what I want to achieve here is to advertise my outgoing traffic, PGP outgoing traffic, but with the condition that I want to prefer specific path for my specific subnet. So under these circumstances, what we have to do, this is the most common asked questions in interview also. So what we have to do, we have to create an access list here, and in that access list, then we have to create a route map, and then on each interface that we have gig 1/1, we have to call that route map that we are going to create it. Okay, so I have already mentioned the steps that we should follow. So let me show you the steps also. So guys, in order to achieve the same ask, what we have to do now, we have to create an access list. We are going to permit my first prefix, which is 1.1.1, and then we are going to create a route map. And as we know, in each route map, we have to match the condition. What we are going to match, we are going to match our first prefix, which is 1.1.1, and after match, we have to do a set command in the route map where we are going to set the interface 1/1. So what exactly we are doing, permitting the 1.1 via access list, and then we are creating a route map where we are matching the IP address that we have defined in the access list, which will be 1.1.1. And then we are asking if it match the condition, then your exit path should be gig 1/1, which is our original ask. And for the subnet 2.22, what we are going to do, we are going to create another route map, and there we are going to set the interface as gig 1/2 for 2.2.2. Once your configuration is done, what we have to do in order to implement the configuration on gig 1/1, that is this interface, we have to call our first route map which we have already created initially. Okay, so in this way, via access list and the route map, what we can do, we are actually influencing the outgoing traffic.
खत्म. बाय बाय, टाटा, गुड बाय, गया.